Hey everybody, John here. I'm going to go through the algebra problems that use whole numbers first, and then the algebra problems that use fractions for the practice midterm for Unit 3. So you should be in level 55 or trying to complete level 55 if you're taking this test. All right, so the first one, I'm going to just skip through. And this is basically what the test will look like for you, but the numbers will be different. First problem is 9x minus 5 is equal to negative 1. Okay, so I've written that out here on my whiteboard. And I want to be sure to mention the existence of this GED formula sheet. When you are opening a test, let's see, is it this one? This one. So the link for the test is right here, and then right below it is this link for the GED formula sheet, and you can use this while you're taking any test that I give. And this is the same sheet that they provide when you take the GED, and this saves you having to memorize all of these formulas, but you will have to know this sheet pretty well in order to use it effectively during a test. So on this side we have geometry, so shapes and linear measures, and then area and square measures, and then volume and cubic measures, and surface area. So those are the three different types of shapes. And then there are some formulas for data, algebra, simple interest, distance formula, and total cost. And then, of course, Pythagorean theorem, which you use in geometry. So just make sure that those all make sense to you. And if any of these don't, like for instance, slope of a line, you can use those as keywords to search at Khan Academy and learn more about those subjects in an interactive video at Khan. Okay, so I'd like to go ahead and introduce, walk through these problems and solve them for you. And this first set is whole numbers and algebra. So algebraic reasoning with whole numbers. So our first one, 9x minus 5 is equal to 1, equal to negative 1. So we always want to solve for x or isolate x. And you can see here in the answer they're saying x is equal to what? So what we want to do is try to pick away everything that's around the x that's stopping us from getting to the x, and just work it down until there's only an x and an equal sign, and then whatever's on the other side of the equal sign, that's what x is, okay? So normally we start at the outside edge, so farthest away from the x, so we have a negative 5 here. So what I'm going to suggest doing, and since we're looking at an equation, we know we can do any mathematical operations here, as long as we do the same thing on both sides of the equal sign. So I'm going to say let's add a 5 here. And if we add a 5 here, we have to add a 5 over here. So these two cancel out, leaving 9x. And that's equal to negative 1 plus 5. Well, that's the same as 5 minus 1, which is equal to 4. And so when we want to do the next step, we will, what's happening to the x now? So at first there was a 5 being subtracted from it, so we added 5s to both sides to get rid of that 5. And now there's x is being multiplied by 9. So we like to use the inverse operation. Oops, inverse operation. And that's like the opposite operation. So the inverse of subtraction is addition. So they were subtracting 5, so I added 5 here. And then I added 5 to both sides. And that left us with 9x is equal to 4. And x is being multiplied here by 9. So we're going to want to do the inverse, which is divide by 9. So we're just going to, and we're going to do that to both sides. And now we have 9x over 9. So 9x divided by 9 is going to be 1x. So these 9's cancel each other out, leaving x. And we don't have to reduce this fraction. It's just 4/9. So believe it or not, if we plug this number, if we plug this 4/9 in here, where this x is, we can substitute that in. We get 9 times 4/9 minus 5 is equal to negative 1. Now let's just work that for fun and see. So if we follow PEMDAS, we're going to do multiplication first. So 9 times this, you could do the shortcut and just say 9 times 4 over 9, the 9s will cancel out, and you'll get 4. Or you can multiply it. You can put 9 over 1 and 4 over 9 and multiply those and get 36 over 9 and reduce that to 4 over 1, which is reducible to 4. And so same difference, right? We have 4 here. So 4 minus 5 is equal to negative 1. And if that's true, then our answer was good. So here, x is equal to 4/9, 4 over 9. And we'll talk a little bit about how to enter numbers as fractions. And they give us a preview, and then they'll tell us if the syntax is okay or not. Okay, so no syntax here, just a fraction. So we're going to click submit. Hopefully it turns green. Awesome. The next whole number problem we're going to look at is Q5. And 2x plus 9 is equal to 3. Let's start with a fresh sheet. 2x plus 9 is equal to 3. So we're going to use, use the same strategy. And so I encourage you to just think about the strategy, doing the same thing to both sides of the equation. Okay, excuse me a second. I noticed that my screen did not update. So let me reconnect. I missed all these valuable notes. Oops. Okay, stop mirroring and start mirroring. There we go. All right, so this is what I was writing when you weren't seeing anything. So for whatever reason, the screen didn't update. So let me walk you back through that. We started with 9x minus 5 is equal to negative 1. So that's all we had to go on. And so to start picking this apart, we want to isolate x, and usually we start far out from x. And in order to eliminate the negative 5 here, we just do the inverse operation, which is addition, and we use the same number. So we're going to add 5, because here they're subtracting 5. And if we do the same thing to both sides, then it will still be equal, okay? And gradually we're going to pick this apart until we've isolated x. So after we did that, we had 9x, excuse me, 9x was equal to 4. So we had negative 1 and positive 5, that's 4. And then we decided to do the inverse operation of 9x. So what's happening with x? It's being multiplied by 9. So we want to divide by 9. So, and if we divide this side by 9, we have to divide both sides by 9. So we did. And 9x divided by 9 gives you x. And 4 divided by 9 is 4/9. And we don't reduce that anymore. It's reduced all the way already. And then to prove this really worked, because it went kind of easy, so I was suspicious. Usually isn't that easy for me. So I plugged that number in, 4/9 in for x up here. We substituted it in. So we rewrote that 9 times 4/9 minus 5 is equal to negative 1. And then I did the quick method, just cancel out the 9s, which left 4, which is 4 minus 5 is equal to negative 1. But then I also multiplied it out. Some people are more comfortable doing that. 9 over 1 times 4 over 9 is equal to 36 over 9, which is equal to 4 over 1, which is equal to 4. So we still got 4 minus 5, and that is equal to negative 1. So 4/9 is the answer. So without having any idea what the answer would be, we found it in just a few steps here. So that's why algebra is so awesome. And you just basically, you repeat the same algorithm. How do we isolate the variable? And we just want to reduce and remove everything from around it until it just says x is equal to whatever, and that's our answer. So, all right, so I've got another page going. Let's see if I can find it. Okay, Q5. 2x plus 9 is equal to 3. So we're going to apply the same algorithm. And what's happening with the 2x now? 9 is being added to it, right? So we are going to use the inverse operation of addition. Inverse operation. And it's like the opposite. addition, subtraction, multiplication, division. And you may notice that those are in PEMDAS, right? They're kept at the same level. So there's a reason they're connected. Anyway, we're going to subtract 9 from both sides. So we have 2x plus 9 and minus 9. That leaves just 2x on this side. And then we have 3 minus 9. So we know about negative numbers. And this is truly a positive 3 and negative 9. When the signs are different, you take the difference between the two numbers, and the sign of the larger number is the sign on the answer. So the difference between 3 and 9 is 6, and the 9 is bigger than the 3, so we take the sign of the bigger number. So 2x minus 2x is equal to negative 6. All right, I'm going to change colors. And so what would our inverse operation be now? What's happening to x? It's being multiplied by 2, right? So the inverse operation would be division by 2. And usually we just write it this way. Make a little pair of fractions. So 2x over 2, the 2's cancel out, leaving just 1x, which we usually write x. And that's equal to negative 6 over 2, which can be reduced if both fractions are even. And if you guys practiced your divisibility rules, you'll know these are both divisible by 2, so let's divide them both by 2. Negative 6 divided by 2 is negative 3. And negative 2 divided by 2 is 1. And this, negative 3 over 1, is equal to, oops, let's just get rid of one of those. Negative 3 over 1 is equal to negative 3. So x is equal to negative 3. And that will be our answer. So we don't have to be able to see the answer or intuit it somehow. It keeps slipping down. We just follow this pattern. We use the inverse operation, the same number, but the inverse operation to get rid of the clutter. And we just focus in, zero in on that variable and find out what it is. And when we get to that last statement, oops, I almost erased it. That last statement, it tells us what x is equal to. So if we plug this negative 3 in up here where the x is, 2 times negative 3 plus 9 is equal to 3. All right? So let's see if that's true. 2 times negative 3, this is PEMDAS, so we do multiplication first. 2 times negative 3 is negative 6, plus 9 equals 3. So negative 6 plus 9, we've got two different signs. So we're going to take the difference between those two, which is 3, and we're going to retain the sign of the larger of the two, which is the 9, so positive 3. And that is equal to 3, so this is our answer. Let's see if we got it right, really. We'll ask WAMAP, did we get it right? Negative 3. Boom, there's a green go light. So we'll go to the next one, Q6. These are going to get a little bit, they should get progressively harder, we'll see. But we're going to apply the same rules as we go. We're solving for x. 16 is equal to negative 4 plus 5x. Okay, so inverse operation, we have a negative 4. So if we do a positive 4, will that get rid of it? And we want to start peripherally, and we just have to do the same operation on both sides to keep it an equation. So let's add 4 to both sides, right? So positive 4 and negative 4 cancel each other out. That's mutual self-destruction, mutual annihilation. 16 plus 4 is 20, and that's going to be equal to 5x. So some of you may already be looking ahead to what we can do with that. What do you think? You know, you've been learning your factors in the multiplication table, so you can see 20 and 5 and the divisibility rules. They're both divisible by 5, so let's take out a 5. Divide both sides by 5. 5 divided by 5 is 1. 1 times x leaves 1x or x. 20 divided by 5 is 4. So now we have our answer. X is equal to 4. And we worked this one a little bit backwards, but the equal sign means that 4 is equal to x and x is equal to 4. These are the same. So that means if we plug this number in at the beginning, we should get, that should be a true statement. So let's just plug it in and see. 16 is equal to negative 4 plus 5 times 4. So PEMDAS, we're going to do 5 times 4 first. 20 plus negative 4 is that 16. So the signs of these numbers are different, so we'll take the difference, which is 16. The larger number is positive, so we'll have a positive sign on our number. 16 is indeed equal to 16, so that's a good answer. So we'll put that in. X is equal to 4. Awesome.